welcome to CEC lectures. Myself Dr. Preeti Chugmani from Department of Computer Science, Arbit College, University of Delhi. So in the series of database management system, the previous topic which we have started was all about the relational model of representation of databases, and now today we will be covering the more details about the relational databases, and then we will be covering the concept of database management keys also. When we talk about the relational model, in the previous lecture we have established that the relational database is going to consist of collection of tables, and each table is assigned a unique name. Now table, when we talk about, is actually a collection of we can say, or a combination of rows and columns. So row in a table is going to represent, we can say, a relationship among a set of values, and table is collection of such relationships, such such rows we can say, and there is a close correspondence between the concept of a table and the mathematical concept of the relation, and that is why this table can be called as relation. So the term relation here refers to the mathematical concept of relational algebra, which is the relation. Now if we talk about the row, row is basically we can say row is also called as a tuple, which is simply a sequence of values, or we can say which is simply a list of values, and a relationship between n such values is represented mathematically by an n tuple of values, that is those tuples with having n values, and this tuple with n values is corresponding to a row in a table. So that is why I was saying there is a close correspondence between the concept of the table and the mathematical concept of the relation, because here the term relation is used to refer to a table, where the term tuple is used to refer to a row. Similarly, every column, which we also called as a field, is also termed as attribute. So for rows we have tuples, for columns we have fields or attributes, and the table itself can be called as the relation. Then when we talk about instances or the relation instance, so instance, as you show, is as you are aware that it is basically a snapshot of a database at a particular time. So when we talk about the relation instance, that refers to a specific instance of a relation with some specific values at a point of time, which is containing a specific set of rows. So for now the point is, how are these values of attributes, or how are these values of data are being derived. So for each attribute of a relationship, for each attribute of a relation, we have a set of permitted values, and that set of permitted values is known as domain of that attribute. So for example, let us take the example of the attribute salary. So that attribute salary of the instructor, salary, which is the attribute in the instructor relation, and it is showing the salary of the instructor. So that salary attribute is something which is deriving its value from the domain of the salary. So basically the domain of the salary is the set of all possible salary values. So for example, let us say the university for which we are modeling the database, or for the college itself we are for which we are modeling the database, says that the minimum salary starts from, let us say, an amount of X, let us say 30,000, something of that sort, and maximum it goes to, let us say, 1 lakh. So any value from 30,000 to 1 lakh can be a salary of the instructor, and this pool of values from which the salary of instructor can be taken, this pool of values is known as the domain of that particular attribute. Now, the domains of all attributes of a relation R can be atomic. So, first of all, let us try to consider what is this atomic domain, and then we will look into the other possibilities. So, a domain is atomic if elements of the domain are considered to be individual units. So, for example, if I am talking about, let us say, just a phone number, without having country code or without having area code or without any other specific prefixes, it is just a number. So, that is something which cannot be divided into further units. So, here we can say the domain is atomic. Now, on the other instance, if we want to treat it as a non-atomic value, then we can have the area code, then we can have the country code, which are the prefixes. So, the country code, then area code, and then a phone number. This type of value can be divided into three parts: area code, country code, and the phone number. So, here we can say it is a non-atomic value. So, it is about the kind of, we can say, treatment of the values or the treatments of the domain, that whether we really want to treat them as atomic or we want to treat them as non-atomic. This is actually, we can say, implementation decision. Another example of atomic and non-atomic is, let us say, we have address field. So, address can be considered as the chunk of characters, or it can be having different values. For example, you may have flat number, then you may have something about the street name or something, then you may have locality within that, and then after locality you can have the name of the city, then name of the state, and then the pin code. So, all these chunks can be considered as one. If they are considered as one, that is the atomic domain, and if they are considered as different, they can be divided into subunits of this locality, flat number, and pin code, and so on and so forth. So, that is actually something which is non-atomic. Now, with this I am coming to my next topic, which is about the keys of DBMS, sorry, keys of databases. So, keys of databases, if I am going to talk about, is how these tuples in a given table are going to be distinguished as in, for example, let us assume the value of an attribute, the values of the attribute for a particular tuple, let us say tuple number 1 is similar to all the values of the attribute of the tuple number 4. So, all the values in tuple 1 are same as all the values in tuple 4. So, if is it a viable situation, is it a situation which is going to occur? If it is going to occur, how are we going to identify the uniqueness of a tuple? This is basically we can say ensured with the help of keys. So, basically tuples within a given table are distinguished with the help of keys, or we can say that no two tuples in a relation are allowed to have exactly the same values for all attributes. For some of the attributes they can have I can say same values, but for all the attributes having the same value for at least two tuples is not desirable at all, because the value of the attributes, the value of the tuples must be in such a way that they can be uniquely identify. So, the concept of keys is going to help us in this unique identification of tuples, or we can say unique identification of values. So, here within the kind of, we can say, concepts of keys, the first concept which comes up is a super key. So, super key is, I can say, a set of one or more attributes. When taken collectively, they allow us to identify relation, tuple in the relation, or they allow us to identify uniquely a tuple in the relationship. in a relation. So, for example, we have this instructor, this instructor table which we have seen earlier. In that instructor table, we have an attribute ID, which can be considered as a super key, because ID is different for all the tuples. No two tuples are going to have the same ID ideally, but attribute name or instructor name cannot be taken as the super key, because two instructor can have similar names. Now, when we talk about this super key may contain extraneous attributes. Extraneous attributes, that means some attributes which are making it as a power set. So, for example, ID is a super key because it can uniquely identify an instructor, and so is the combination of ID and name is also a super key. That is so here the name is that extraneous attribute which I was talking about. So, let us say I can say generally speaking, if I can say K is a super key, then any other superset of this K will also be a super key. So, now if ID is a super key, then ID plus name is also a super key, then ID plus name plus department is also a super key. But with this super keys, we have got another concept of candidate keys. So, candidate keys are minimal super keys for which no proper subset is a super key. Now, what does this mean? So, we can say candidate keys are the important, the bottom line here is candidate keys are the minimal super keys. So, for example, suppose that a combination of name and the department name is sufficient to distinguish the values within a relation. Let us say we talk about the instructor relation. Then we have two things here, or two candidate keys. One is ID. So, ID is also capable of identifying the tuples uniquely, and so is the name and department name. Name and department name both in combination are also, we can say, also allowed or also capable of having identifying the tuples uniquely. So, both these keys are known as candidate keys. One is the ID, another one is the combination of the name and the department name. But if we talk about these attributes individually, the attribute ID and name together can distinguish the tuples. Their combination ID and name does not form a key, since the attribute ID is alone a candidate key, because I was talking about the minimal super key is the candidate key is the minimal super key. So, if ID itself is the candidate key, the combination ID plus name can be a super key, but cannot be a candidate key, because having supersets is allowed in super key, but if we talk about the candidate key, it has to be the minimal. So, if ID is able to distinguish the tuples uniquely, there is no need, or having ID and name in combination as a candidate key is not allowed. Now, here we have seen the concept of super key as and also the candidate key, and we have also seen that within our instructor relation or within our instructor table, we have two candidate keys. One is the ID, another one is the combination of name and the department. Now, let us say as a database administrator, or I as a designer of the database, have to take a call that which particular candidate key among these two I am going to be I am going to choose as a principal means of identifying the tuples. that particular candidate key, whether it is ID or the combination of name and department name, which is actually chosen by the database designer as the principal means of identifying tuples within a relation, is known as primary key. So, ID can be a primary key, or the combination of name and the department is also capable of being a primary key. It is about the database designer who is going to take that particular primary key as its as his or her choice. Also, when we talk about key, whether it is a primary key, candidate key, or it is a super key, is the property of the entire relationship. It is not the individual feature, or it is not the individual property of any tuple. When any two individual tuples in the relation are prohibited from having the same values on the key attributes at the same time. Whatever the key attribute is, whether we are talking about the primary key or whether we are talking about any other, the same values of these keys are not allowed for two tuples. So, primary key, now the point is, if we have choices of let us say we have n choices of candidate keys to be taken as primary key, but one of them has to be chosen as the primary key. Now, the question comes up, which is going to be the best choice for a primary key. So, we can say that the primary key should be chosen such that its attribute values are never changed, or even if they are changed, it is going to be a very, very rare phenomena. For examples, we can say the address field. Address field cannot be taken as the primary key, because there are chances of a person changing the addresses. This can happen very frequently if a person is putting on a rent, and that is a very practical scenario. So, that means address is going to be changed. So, we should not keep all these keys as the primary keys which are going to be changed, but yes, Aadhaar number of a particular individual can be definitely taken as a primary key, because it is such a number which is not going to change ever. So, Aadhaar number can be taken as the primary key, but not the we can say address field, then or even phone number also. Then we have how to represent this primary key. So, while we are representing a relation schema, we need to underline the primary key attribute. Also, this primary key attribute has to be listed first. So, a relation schema can be for the relation instructor, it is going to be written as, within the brackets, it is going to be written as ID, name, department name, and let us say course. So, ID, name, department name and salary, sorry. So, ID, name, department name and salary. So, the identification here or primary key here is the ID. So, ID will be written first, and also you need to mark and underline at the bottom of the term ID. Now, we have many, in a database we have many relations. For example, we have, let us say, a one relation R1 and another relation as R2. Now, for example, in the relation instructor, we have this department name. Now, this department name is, let us say, coming from another relation which is about the department and its code. So, for example, we have three departments. One is computer science, another one is maths, and third one is stats. So, computer science has given as C1, the code as C1, maths as M1 and stats as S1. While forming the relation instructor, we are going to name, we are going to specify the department, and department has to be one of these. Either it can be statistics, or the department can be computer science, or the department can be mathematics. So, here in the department relation, the name of the department or the department itself is a primary key, but when it is brought in the instructor relation, then it is known as foreign key. So, for example, let us say we have a relation R1. This is going to include its attributes, along with its attribute is having the primary key of another relation, say R2. So, from department we have taken the names of the department and we have put in up here. So, instructor number 1, let us say he or she belongs to M1, instructor number 2 belongs to S1, instructor number 3 belongs to C1, instructor number 4 also belongs to C1. So, department name here is known as foreign key, which is coming from another table. So, a relation R1 may include one of the attributes of the primary key from another relation, assuming the name of the relation is R2. The attribute is called a foreign key from R1 referencing R2, and the relation R1 is also called the referencing relation of the foreign key dependency, and R2 is also called the referenced relation. R1 is called the referencing relation and R2 is called the referenced, R1 is called the referencing relation and R2 is called the referenced relation of the foreign key. So, you know, this concept of foreign key is actually very important when we start, you know, designing the database. So, for example, the attribute department name in the instructor is a foreign key referencing department. Since department name, it is the primary key of the relation department itself. Now, with the, you know, we can say concept of the super key, candidate key, primary key and foreign key. Now, let us try to understand the term integrity constraints. So, integrity constraint is something which is, we can say, it is set of rules which is imposed in order to maintain the quality of the data or in order to maintain the quality of the information. These integrity constraints ensure that insertion, updation and all other processes of the data are to be performed in such a way that the integrity of the data should not be lost or should not be affected. So, integrity constraint, when, you know, put in up in the database, is used to guard against the accidental damage to the data, we can say. Now, what actually this integrity constraint is, that will be very clear when we talk about the examples of these examples and types of the integrity constraint. So, this integrity constraints can be of you know, 4 types. One is the domain constraint, another one is the entity integrity constraint, then comes referential integrity constraint and then comes key constraints. Let us try to understand them one by one. Starting with domain constraint. Domain as it is the, you know, pool of values from which the value for a particular attribute has to be derived, that we have seen. So, domain constraints can be defined as the definition of a valid set of values for an attribute. So, for example, the data type of domain includes, it could be either character, integer, time, date, currency, etc. and the value of the attribute must be available in the corresponding domain. So, for example, let us say we have a relation in which there is ID, name, semester and age. Now, if we consider age, this has to be an integer and the domain of age, domain of the attribute age can be, you know, starting from if we are talking about this as a, you know, student. So, we can say 15 years to maybe let us say 80 years or so. So, anything between 15 to 80 could be, you know, we can say is the value which is valid for age. Now, within this age, if we are going to write the value as a, as it is shown on the screen, so it is not allowed because age is an integer attribute, and this constraint that age is an integer attribute is actually the domain constraint, we can say. With this, we come to the next, which is entity integrity constraint. So, entity integrity constraint says the primary key value cannot be null because it is something which is used in order to identify the individual rows, individual rows in a relationship. So, the table cannot contain a null value other than the primary key field. So, for example, here we have a relation employee in which employee ID for 3 tuples are given, but for 4th it is not given. So, if we have declared employee ID as primary key, this will not be allowed because primary key cannot contain a null value, and primary key cannot contain a null value is actually an entity integrity constraint. Then coming to the next one, which is referential integrity constraint. Referential integrity is about the foreign key, we can say. It is a constraint which is specified between two tables. Let us try to understand this with the help of an example. So, here we have one table, table 1, and another one is the table 2. D number, D underscore number is a number which is the primary key in table 2, and it is serving as the foreign key in the table 1. So, here from it is from table 2 it is marked as the primary key. So, here it cannot have any null value, but when we talk about taking up this D underscore number as a foreign key in table 1, any other value which is any value which is not contained in the primary key will not be allowed in the secondary key. So, for example, here the values 11, 24 and 13 are there, but there is no value which is 18 specified in the third row of the table 1. So, we cannot have any value which is not available in the primary key, but we are introducing it anew in the we can say as a new value in the foreign key attribute. So, that is not allowed. So, here the number 18 is not allowed because it is not mentioned inside the primary key attribute. Apart from this, the last one is about key constraint. The key constraint says the duplication of primary key is also not allowed. As you can see here on the screen, we have ID and name. ID when declared as the primary key will not have the duplicate value. It is not having the null values. It is specified under primary key constraint, entity integrity constraint, but it should not have the duplicate values as well. This is specified as a key constraint, or in many of the literatures you will find the entity integrity constraint saying the two things together, that the primary key should not have a null value or a duplicate value also. So, you can take it that way also. So, in this way we will be having 3 constraints. One is the key constraints, another one is the entity integrity constraint, and then we will be having a referential integrity constraint. So, here in this lecture we have seen the concept of constraints as the domain constraints, entity integrity and referential integrity constraints, and before that we have also seen the concept of keys as super key, primary key, foreign key and candidate key. And with this I am going to close this lecture here. Here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. Thank you for a patient hearing.